Okay, this is lesson 5.2. This is the second day of it, and this is Monday, April 16th, so I assume you're listening to this sometime today. And what we're going to do, it's more verifying trig identities, but the thing about an identity is, that's kind of interesting, is they give you the left side of the equation, and they give you the right side of the equation. So they're giving you both sides of the equation, so they're kind of telling you the answer already. You're just making sure that the left side really does equal the right side, and that the right side does equal the left side. So in one sense, they're very, very tricky, but in another sense, it's kind of hard to get it wrong because they're giving you both sides of the equation, so you know at the end of the day what your answer should equal. So before we start these, one thing you always need to remember, we practiced this morning already, or this afternoon already, just you know your basic trig identities. And let's just flip to those. It's on the back page here. So that fourth page, it's got them here. Do you know your reciprocal identities? Do you know your quotient identities? Do you know your Pythagorean identities? All these will come into play in these problems, and again, those you'll want to be just very, very familiar with, and we practiced those already this afternoon, so hopefully you're already somewhat familiar with them. Okay, so verifying identity, what we want to do is we want to start on one side of the equation, typically the left side, and make the left side, go through identities, and make the left side look like the right side. And if we can do that, then we are done. Whenever you're doing one of these, I said, typically start on the left side. You typically start on the more complicated side. You can kind of argue here, what is more complicated? Cotangent plus tangent, or secant cosecant, which is more complicated. And generally the side with an addition or subtraction is the more complicated side. It's easier to know what to do. You're going to add up the fractions. So given one like this, we're going to start on the left side. We're going to somehow try to make this look like secant times cosecant. When we get that, the left side to look like that, then we'll know we're finished. Okay, so let's start. We have a cotangent plus a tangent. You think through your identities, and again, I always lean towards sines and cosines, so I know my quotient identities, and cotangent is cosine over sine. Or tangent I know is sine over cosine. I'm going to work exclusively on the left side, so I've done that on the left side. Now on the left side, I see I have a fraction. How do you add fractions? You get a common denominator, so I need a sine and a cosine. So for these fractions, I need a sine and a cosine. My fraction here, cosine times sine, how do you go from sine on the bottom to sine and a cosine? I've got to multiply the top and bottom by cosine. So that becomes cosine squared, because look, I took both the top of the fraction and the bottom of the fraction, the bottom, right there, times cosine. So I took this times cosine. I took the bottom times cosine, so I get cosine squared over sine cosine. Now when I look at the second fraction here, I had the cosine, now I've got a sine, so I'm going to multiply the top and bottom times sine of x. So the top times sine, the bottom times sine. And on top, look at that, I get sine times sine, which is sine squared. In the bottom, I get this sine times cosine. And I've still got my plus here in the middle of it. Now with fractions, when you have a common denominator, you can use that common denominator, which is sine cosine, and you can add the tops. So in the top, I get cosine squared plus sine squared. Maybe now you're seeing how this is going to work out. Because on the top, cosine squared plus sine squared, that should ring a bell. That's a trig identity, one of your Pythagorean identities. If you forgot it, again, look at that back page. Cosine squared plus sine squared is right there. I can take that out, cosine squared plus sine squared, and I can put in a 1. So I will do that. And cosine squared plus sine squared is 1. So this whole side now equals 1 over sine times cosine. It's never bad when you're verifying these identities to kind of sneak a peek over to the right side and say, wait, what am I trying to get? Am I done yet? And I'm not done yet, but I'm not far, because I know 1 over sine is the same thing as cosecant. I know 1 over cosine is the same thing as secant. So I get cosecant secant, and I know multiplication is commutative, so that's the same thing as secant cosecant. So I've taken the left side, I've shown by using my quotient identity here, by adding fractions here, by using the Pythagorean identity here, and then reciprocal identities. So this is not easy. I've shown the left side equals the right side, so I've verified the identity. All right, let's try this a couple more times. And again, they kind of grow in difficulty, but hopefully you're thinking that's not too bad. I can handle adding fractions. And it's good for the trig part. It's good just for the review of your algebra. How do you add algebraic fractions? Okay, here's our second one. Excuse me. I've got cosine over sine times cotangent. I want to show that whole thing equals 1. So what's the more complicated side? Right here, the left side. Several approaches to this. I've assigned this in other years, and I know people take several approaches. I'll show you one approach. There's cosine. There's sine. Leave those alone. And cotangent is cosine times sine. So I'll sub out the cotangent. I'll use a quotient identity, and cotangent is cosine over sine. Now I'm focused on the bottom of the fraction. So the top stays cosine. On the bottom, I'm multiplying. And I know when I multiply fractions, I can cross-cancel. And I can cross-cancel those signs. And all that's left on the bottom is just this one little cosine. So I get cosine over cosine, and cosine over cosine reduces to 1. And that's exactly what's on the right side. So I verified that identity. All right, not too bad. One last problem. This one looks a little bad. There's a sine over 1 minus cosine minus sine cosine over 1 plus cosine. We want to show the whole thing equals cosecant times 1 plus cosine squared. If you can figure this one out on your own, then there's nothing that's going to stop you. This is as complicated as these get. Okay, I would start on the left side. I've got the addition or subtraction. That's the more complicated side. I've got a fraction. How do we subtract fractions? Get a common denominator. So I need a 1 minus cosine, and I need a 1 plus cosine. I have the two different parts. Here was the 1 minus cosine. Here's the 1 plus cosine. So I need both parts for my common denominator. My left fraction, we have to multiply by the top and bottom by 1 plus cosine of x. So I took the top and bottom times 1 plus cosine of x. And my right fraction, I already had the 1 plus cosine, so I'm going to multiply by the 1 minus cosine. So I take the top and bottom of the fraction times 1 minus cosine. Okay, that was step 1. There's all sorts of things going on here. We might do a couple steps in one here. Hopefully you can follow this. On the bottom, I've got my common denominator, so I'm just going to write that again. I think we'll just do one step at a time here. So I'll keep my bottom. And now I can actually subtract these fractions, and I'm going to distribute as I'm doing it. So I get sine of x plus sine x cosine x. And now for my second fraction over here, when I distribute, and don't forget we've got this negative in front, when I distribute this, I get minus, I get sine cosine times 1, so minus sine x cosine x times 1. And then I've got minus a negative, so I've got plus sine x cosine squared of x. And it's kind of starting to take shape just a little bit. On the top of the fraction, I notice sine cosine minus sine cosine cancel out. And one more thing on the top of the fraction I could do is I could notice both the first term and the second term have a sign in common, so I can factor out that sign. So the top I'm going to write as sine, I'll factor that out, times 1 plus the cosine squared. All right, and the bottom stays the same, 1 minus cosine, 1 plus cosine. Let me give you a peek, sneak a peek at the right side. We're kind of getting there. I see the 1 plus cosine squared, but we've got more work to do. So now we'll focus on the bottom. So top is sine x, 1 plus cosine squared of x. The bottom, I'm going to FOIL this out. So FOIL, remember FOIL? First gives me 1. Outside is plus cosine x. Inside is minus cosine x. and last is minus cosine squared of x. I notice the two middle terms cancel out. Cosine minus cosine cancel out. And I've got the sine on the top. I've got 1 plus cosine squared of x. And the bottom I've got 1 minus cosine squared of x. And all sorts of good algebra going on here. One thing to realize is I can't cancel out the cosines or something like that, because I've got this whole term, 1 minus sine squared, or sorry, 1 plus cosine squared, or 1 minus cosine squared. So it's got to be a perfect match to cancel out, and I can't do that. Instead, I take a look back at the Pythagorean identities, and I'm looking at the bottom of my fraction, and I look over here, I circle, let me just uncircle that. I'm looking at this identity again, and I realize if I subtract cosine squared from both sides, then sine squared is 1 minus cosine squared. So that was the bottom of the fraction. 1 minus cosine squared is the same thing as sine squared. So let's come back and look at this. And guys, we are almost there. So I keep the top of the fraction, sine x, 1 plus cosine squared of x. And the bottom, that was my Pythagorean identity rewritten. 1 minus cosine squared is sine squared. Look at that fraction. One of the signs is going to cancel out. So I've got the sign on the bottom of the fraction, but the sign on the bottom of the fraction is the same as the reciprocal, the cosecant, on the top of the fraction. And I end up with that identity. That was a very, very tricky problem. That's a problem for an A+ student, which we have in the room. Hopefully you're thinking, wait, that's me. But we have some A+ students, and that would be a problem that would challenge anybody. The first two, hopefully, are a little more accessible. You think, okay, I can handle those two. And this one may have given you a run for your money, which is okay. But that completes our lesson. We're verifying identities, and to do that, we're using our fundamental identities.